Hello everyone. In this video, we'll understand the concept of limit. Let's consider a function f of x equal to 2x. If x is a number approaching 2, means not exactly 2, then f of x will be a number which will approach to 4. Let's understand this through this following table. For example, if I consider x as 1.9, then f of x will become 3.8. Then slowly I'm increasing the values of x, means 1.99, it becomes 3.98. If it is 1.99, it becomes 3.998. Like that, 1.99999, it becomes 3.99998. And further, if I increase beyond 2, if it is 2.00001, it becomes 4.00002. Means if we look into these values here, x, whatever x values are there, just lesser than 2. And here we may notice x is greater than 2. And when x approaches very, very nearer to 2, this f of x is also very, very nearer to 4. Similarly here, when it approaches from positive side very, very nearer to 2, it becomes 4 in f of x. So this, we call it, the first one, we call it as left hand limit, means we can say this one. This situation is defined as left hand limit of f of x as x approaches to from the left of it and is denoted by, we can say LHL, left hand limit, and it is denoted by limit f of x is approaching to, I'll put on the top as a superfix -1, negative minus sign, and that will be 4. Similarly, in this situation, we call it as right hand limit, and here limit is written as x approaches to positive, that is also 4. So we can say here, we can say limit x tends to 2 minus f of x is the same as limit x tends to 2 plus f of x, and both are equal to 4. Thus, we can conclude limit x tends to a, in general, f of x is said to exist when both left hand limit and right hand limit exists and they are equal. So that we write it as limit x tends to a from its left side of f of x is same as limit x tends to a from its right side f of x, and that we call it as the limit x tends to a f of x. So this is basically the concept of limit, and now we will understand some of the useful rules of theorems on limits. Let us consider limit x tends to a, f of x is L, and limit x tends to a, g of x is m, where L and m are finite quantities. Then we can say limit x tends to a, f of x plus or minus g of x, means these two functions can be splitted into two different limits. Limit x tends to a, f of x plus or minus, limit x tends to a, g of x. And we know this value is L and this value is M. So we can write final result as L plus or minus M. Similarly, for the product, limit x tends to a, f of x multiplied by g of x can be splitted into two limits as limit x tends to a, f of x multiplied by limit x tends to a, g of x, which is L into M. Same way is the case for division also. Limit x tends to a, f of x divided by g of x will be, I can split for separately two limits for numerator and denominator. Limit x tends to a, f of x divided by limit x tends to a, g of x, which is nothing but L by M. Now further, we can also say limit x tends to a, c, where c is a constant, will be c only because there is no x involved in this function. Now, if limit x tends to a, c times f of x, where c is a constant, again c can be taken outside the limit and we can write it as limit x tends to a, f of x, which is nothing but c times L. Then a function of a function, limit x tends to a, capital F of x can be written as capital F of limit x tends to a, f of x, which this one we know it is L. So we can compute it as capital F of L. So these are some of the useful rules of theorems on limits.